Hi, my name is Ivana, and this is Sven, and today we would love to share with you 3 passions of ours combined into this one talk. The first one is being curious about the world that surrounds us and wanting to learn about everything and anything.
Yeah, and the answer to the next question is hopefully obvious. Who likes visualizing data with Grafana? You don't? Okay. Yeah, the next one is rather a niche question, and it's kind of the decider if this talk is going well or not. Who likes hearing bird songs? Okay, that's fine enough.
Oh, nice. A lot of raised hands. So for everyone who raised your hand, but also for everyone else, we have a perfect thing for you, a bird song. Is anyone familiar with this bird? Or can you name it? Yeah, correct. It's cuckoo, and if your native language is not English, maybe you will know it under one of these names. Me and Sven really like this tweet because it perfectly describes our own experience with birds. But today we are not going to be talking only about birds. We are also going to be talking about observability and about integrating observability into something tangible. So something that you can touch, something that you can see, or that you can hear. We'll talk about how to select important metrics, how to source them. We will build beautiful dashboard, conduct investigations, and make this whole thing actionable. So let's start with getting the most important data about bird songs.
Yeah, so bird songs and observability. How do we bring those 2 topics together? And the idea here is to use an application that detects bird songs and build an observability system around that. But how did we actually do that? And the key application in our system is an application called BirdNET. And BirdNET is an AI-powered bird sound recognition application. It's built by the Cornell Lab of Ornithology and the Chemnitz Institute of Technology. And yeah, what BirdNET really is, it's like a big machine learning model, and it can detect up to 6,000 species now, mostly across America and Europe. And one of the coolest things here to mention is that it's mostly open source, so it's an open source platform. And I say platform because you have to distinguish between a mobile application that is kind of closed source, but has around like 50,000 daily active users. And all that data that is collected via this mobile application, that data is fed back into the system of the Cornell Lab, so it can be used there by scientists. That's why it's also a citizen science project. And the other part is like an analyzing system that is actually open source. And we can use that to build our observability system around that. And to better help understanding how BirdNET actually works, it's good to visualize the data we get from BirdNET. Yeah, so that view is called a spectrogram. It's a visual representation of the frequency and the volume over time of an audio. And that helps turning this complicated task of audio recognition, turning it into a more easy task like pattern or image recognition. Because in the end, you see a pattern, you see an image, right? And you can then use a machine learning model to train that and use that to detect the species in the end. And yeah, by the way, the birds we just heard was a common wood pigeon and a chiff-chaff. And with that, let's have a quick look at the infrastructure we are using here. And on the left, there's a microphone, just a $25 microphone from Amazon, really. We connect that via USB to a Raspberry Pi, and on that Raspberry Pi, we use the BirdNET application that's running there. And then, obviously, we need some kind of network connection, to either go to the Raspberry Pi or send data from the Raspberry Pi to the internet. Basically, very simple. Those are 2 actual pictures. So on the left, this little weird-looking thing is like the microphone with a little pop filter on top. at my balcony, and then obviously the Raspberry Pi in a small case. Let's jump into the data we get really from BirdNET, and we can use to build our system around that. And BirdNET makes this task very easy because it just logs the detections. And at the top, we can see some sample log lines, and those contain really like every data we really need. So on the far left, in yellow, we see the timestamp of a detection. In orange, we see the name of the species, both in like the scientific Latin language, but also in English language. And then on the end, we have a number. And that number is the confidence value, which is kind of a number between 0 and 1, so a percentage about like how confident BirdNET is that the detected species, no, that the recorded audio is actually the detected species. And going back to our infrastructure now, we want to store those logs somewhere. And I mean, for us, it's quite obvious. We want to store them in Loki. And in fact, like we want to use Grafana Cloud's offering, so Grafana Cloud Logs instance. Question still is, like, how do we get the data from the Raspberry Pi to Loki? And I think for all of us, that's now also obvious. We use Grafana Alloy for that, because Grafana has that solution for us. And we run Alloy as a small service on the Raspberry Pi that kind of scrapes the logs and sends them over to Grafana Cloud for further processing. And with that, let's have a look at the data, at the dashboard we built, just using the data in Loki, and Grafana is the visualization tool here. So for example, we can see at that day we had 9 distinct species, and we used a small state timeline diagram here to see all the species over time. The great spotted woodpecker was very active in the afternoon there. And also we have information about like every bird at the bottom. This one is the Eurasian blue-tit. It's very active during the whole day, and we have like 18 occurrences of that. So in a very simple overview, we use Grafana and the strength of like visualization data and Loki to store the logs. And how we can enrich that data, Ivana's going to talk about.
Yeah, so now when we have the most important data, so data about bird songs, we can start considering other data that would provide additional context. BirdNET can recognize over 6,000 different bird species, so it's almost impossible for anyone in here to know how each bird looks like, how it sounds like, or even like a short summary fun facts about it. Additionally, it would be useful to know circumstances in which these bird songs occurred. For example, what was the weather like? Was there any significant pollution? Maybe Sven had a garden party that disturbed all of the birds. Sourcing all of this by ourselves would be a tremendous amount of work, and most of it is out there somewhere. And as we all know, one of the greatest things about Grafana is that your data doesn't have to live in one single place, in one single database. It can live anywhere, and you can simply connect it in one dashboard or even in one panel. So instead of building this massive monitoring that would have to monitor basically whole environment, we decided to search internet for the data, and here is what we found. So we are using Wikipedia to get information about a bird, its image, and audio clip with its song. To query Wikipedia, we use Infinity Data Source, and you can see its logo in the circle. And as you can see from the diagram, it's one of our most favorite data sources, and we've used it a couple times to query different APIs. And we really like it because it, first of all, allows you to query different APIs, but it also then helps you transform different sorts of results to your liking. Then we are using OpenMeteo to get weather conditions. We are using Google Sheets to track observations and experiments. And when I say observations, these are any events that could have any effect on birdsong. So for example, construction work, or maybe Sven's garden party. And when I say experiments, we also did a little experiment with a bird feed, so we are tracking it here as well. For air pollution data, we are using air pollution website called Wacky. And Wacky is great, but it comes with one limitation, and that is it provides data only for past 3 days. But we want air pollution data for every day, so to solve this, we are using a feature in Grafana called recorded queries. And with recorded queries, Grafana runs requests to Wacky every 10 minutes, and then stores the results in Mimir. So then, in our dashboards, we are just querying Mimir, and we have air pollution data for every day. Last but not least, we are using data from eBird platform. Maybe some of you know about it. It's a platform where people can share what kind of bird did they see in their area. Another huge benefit of Grafana is countless available visualizations, many of them created by our amazing community. Maybe some of you in here have created some. And in our project, we are using state timeline, geomap. We are using dynamic text panel created by Volkov Labs to show images and to show or to present audio clips. Table panel, stats panel, and time series panel. So let's have a look at finished dashboard. We are visualizing bird data in relation to other factors that we talked about. For example, temperature, humidity, precipitation, sunshine duration, sunrise and sunset data, or even air pollution. Then, in GeoMap panel, as you can see, we are showing what birds have been seen in the area where Sven lives, so in northern Germany and southern Denmark area. And for every bird, we have created a dedicated section where you can see its image, short description, and audio clip. And you can even play the audio clip. And of course, we see data about bird songs in relation to all other factors that we've already talked about. We also created this dashboard that's basically just an image of every bird that was recorded in the past year in Sven's garden. And fun thing about BirdNET is that it recognizes birds, but it also recognizes other things. So as you can see, we see dog, so it can recognize dog barking, sound of engine, or at the bottom, there's a frog. Moving on to our observations, investigations, and learnings. So first of all, I have mentioned before that we are using Google Sheets to track our observations and experiments. Then we visualize them as annotation in panels, so it's very clear to know when was that event happening. In this panel, we are seeing Easter bonfires, which is a tradition in Germany that was happening a couple of weeks back. And as you can see, the bonfires increase the air pollution, and then we see a significant drop in number of the bird songs. You should keep in mind that bonfires are usually during sunset, evening, so we are expecting the number of songs to drop. But usually, birds are singing till 7:30, 8:30 p.m., and here there is a sharp decline at 7:15. But if you would like more bird songs, our experiment with leaving bird feed out was very successful, and as you can see, it has attracted Eurasian magpie. So if you would like to have more birds in your area, just leave the bird feed out. We've analyzed also bird songs data in relation to sunset and sunrise data, and we very scientifically have categorized birds in these 4 groups. First one is night singers, so it's birds who sometimes also sing at night, and we have here redwing as an example. Then we have dawn singers, so those are birds who usually sing 1 to 2 hours before the sunrise, and we have here European robin and blackbird. Then we have very broad category because most of the birds sing during the day. So as an example, we have here pigeon, magpie, and gray-tit. And the last category is the dawn singers, so birds who also sing after the sunset. And here we have common chiffchaff or Eurasian blue-tit. We also were looking into weather factors and trying to see if any of these weather factors had any effect on number of the bird songs. And as you can see from this visualization, temperature, specifically too low of a temperature or cold weather, has effect on bird singing habits, and birds are singing less than usual. They're probably protecting their energy.
Yeah, so that's pretty cool already, right? We have a lot of data. We have beautiful dashboards. We even don't have to go out anymore to listen to birds. So what now? We wanted to turn that also into something actionable. And actually, we have an alert for Matt's favorite song, the blackbird here. We see it firing at 7 in the morning, so that's a nice way to get up and wake up to hearing to the Eurasian blackbird. And we are also still waiting for this one to fire and to give the Atlantic puffin a visit. The backstory here is when Ivana was creating the dashboards and was looking into the data, she saw a detection of the puffin at the middle of the night. And yeah, I'm super curious if it's going to visit me again, or maybe if it was a false positive. Who knows? Actually, that is an Atlantic puffin, for all of those who didn't know. Super cute, right? Yeah, alerts, we also have SLOs with the great SLO app in Grafana Cloud. And the backstory here is, I noticed that BirdNET doesn't even only detect bird sounds, but also sirens from emergency vehicles. So now I have a SLO to help me monitor the nearby fire department and maybe go out to complain about too many sirens or just have a look at fire trucks, I guess. I mean, burn rate alerts get a different meaning with that, I guess. Well, without jokes, all the steps we did in our little journey can easily be shared to real or business use cases. Even though looking at CPU or memory load is not that exciting as watching puffins or listening to chiffchaffs, the steps of gathering metrics, enriching them, correlating them with other signals, visualizing them in Grafana, making them actionable, those steps can be shared across a lot of use cases. And we just use birds as an example. So basically, every occurrence of bird can be replaced by another metric, for example, by CPU. And yeah, last but not least, we don't want to hold our great dashboards and the data we gathered back, so we created 2 public dashboards. Scan the QR codes, or wait for the links later. And with that, thank you all for listening, and happy birding.